Namaskar and welcome back to Pal Talk Statistics. I'm your host, Dr. Chinmoy Pal, and I'm here to make statistics simple, logical, and relatable.
And I'm Ria, your co host. In today's episode, we are going to decode one of the most useful tools in the world of statistics and data science regression analysis.
Regression. It's one of those concepts that shows up everywhere. Economics, engineering, healthcare, education, you name it. It helps us predict, understand relationships, and even make informed decisions.
Target Segment 1. What is regression analysis?
So let's start with the basics. What exactly is regression analysis?
Simply put, regression analysis is a statistical method used to examine the relationship between one dependent variable and one or more independent variables.
In common terms, it helps answer questions like, does spending more on advertising increase sales? Does temperature affect electricity usage? Can we predict student marks based on study hours?
Exactly. Regression shows us how variables move together and even allows us to predict the value of one variable based on others.
SKA?
Segment 2. Types of regression.
There are several types of regression, right?
Yes, depending on the number and nature of variables, the most common are simple linear regression, one independent variable, one dependent variable. Example, predicting salary based on years of experience.
Multiple linear regression, more than one independent variable. Example, predicting house price based on location, size, and age.
Logistic regression, used when the outcome is categorical, like yes or no, or 0 or 1. Example, predicting whether a student will pass or fail.
There is also polynomial regression, ridge, lasso, and even non-linear regression, more advanced but very powerful.
Segment 3. Simple linear regression explained.
Let's focus for a moment on simple linear regression. Its formula is y equals a plus bx plus e, where y is the dependent variable, x is the independent variable, a is the intercept, b is the slope, that is, how much y changes when x increases, e is the error term.
Let's take a basic example. Suppose we want to predict marks based on study hours. We collect data from a few students, run regression analysis, and find the line that best fits the data. That line becomes our prediction model.
Segment 4. What does regression tell us?
Regression helps us with three things mainly: prediction, estimate unknown values, understanding influence, which variable impacts the outcome the most. Model performance through metrics like R-squared, p-values, and standard error.
For example, if we find r squared is 0.85, it means 85% of the variation in the dependent variable is explained by our model. That's a pretty strong relationship.
Segment 5. Assumptions and cautions.
Now, every statistical method has assumptions. Regression is no different. Some key assumptions are linearity between variables, independence of observations, homoscedasticity, that is, equal variance of errors, normal distribution of residuals, no multicollinearity in multiple regression.
If these assumptions are violated, the results can be misleading. So always check your data and diagnostics.
Segment 6. Real-life applications.
Let's not forget, regression is used everywhere. In finance to predict stock prices, in medicine to assess risk factors for diseases, in marketing to optimize advertising budgets, in education to analyze student performance.
Even in sports, regression is used to predict performance, wins, and team strategy. It's truly a universal tool.
Segment 7. Summary.
To wrap up today's episode, regression analysis helps us understand and model relationships between variables. It's useful for prediction, explanation, and strategy building. Many types exist, from simple linear to complex logistic and beyond. Make sure to check assumptions and interpret results carefully.
And once you master regression, you'll find it's not just a statistical tool, it's a lens to view real-world patterns. That's it from today's episode on regression analysis.
Thanks for listening to Pal Talk Statistics. If you like this episode, please follow and share with fellow learners.
Saying goodbye. Stay curious, stay statistical.